Okay, we've been given this graph here which represents the depth of water in a tank and how it decreases over time. And our first task is to calculate the gradient of this graph. No problem. So gradient is rise over run. So let's choose this point and this point to calculate the gradient over. These are the two obvious points. It'll make our life much easier. Of course, you can calculate gradient between any 2 points on the line, but these two are the obvious choice. So, looking at the graph, if you read off the value, that point there is at a depth of 210 centimetres. And that's at 140 seconds. So, from there to there, the rise is, it's a fall actually, so it's going to be negative. It's from 210 to 0. So that's equal to minus 210, because it's a fall. The rise is actually a fall. It's going to be a negative gradient. And the run is from 0 to 140, which is just 140. Okay? So that's equal to 21 over 14 is minus 3 over 2, which is minus 1.5. Okay, so that's the gradient. Explain what this gradient represents. Well, a gradient is a rate. Okay? Whenever you calculate the gradient of any graph, you're looking at the rate of something, whatever's on the y-axis, compared to, in this case, time. So, in your exam, I would say something like, the gradient shows the rate at which the depth of water is falling in the tank. Just use the word rate, okay? If you get asked a question like this in the exam, get the word rate in there. And you can kind of tell that it's rate from the units, okay? The units of this gradient is rise over run. Well, the units of the rise, that's the y-axis, that's centimetres, divided by run, that's seconds, centimetres per second. That kind of gives you a feel for what the gradient is. It's a rate meaning per second. In this case, the unit on top is centimetres. It's the rate of change of depth, centimetres, per second.